Cool. So welcome, everyone. I hope you are able to see the screen. My name is Nalini. I work for HashiCorp as the Partner Solutions Engineer. And today I'll be taking you through what is HashiCorp Boundary and how can we use it to secure the workloads in AWS. So welcome to the session. Before we begin, just a little bit of housekeeping. If you have any questions, you would see two tabs on your Zoom client. One is Q&A and the other one is webinar chat. So please use the webinar chat because if it's Q&A, the others cannot see your questions. I think only myself and Melanie will be able to see. So it's better to use a webinar chat and post your questions there. And I'll keep an eye on the chat and try to answer as much as I can. So I'll try to finish my content in around 35 minutes and then open the floor for Q&A. But definitely in the meantime, if you have questions, pop it in the chat and I'll try to answer as I go. All right. So I think we do have enough people to begin. Cool. So even before we begin, what is HashiCorp Boundary and what are its benefits? I think just a quick refresher because we are running a 4-part webinar series. So if you have attended the first 3 parts, it's great. If you haven't, let me just give you a quick refresher. Because every vendor out there in the world has their own definition of zero trust and they have their own framework. So what do we think of zero trust security and what does HashiCorp zero trust security framework look like? So basically anything that says zero trust, it begins with identity and it begins with access control. So identity is not that simple, especially in the modern world. The challenge is that it is complex. And as we are growing from traditional infrastructure environments into the multi-cloud or hybrid cloud environment, the identity becomes more and more complex. So if you look at the diagram, there are different types of identities that we talk about in the Zero Trust framework. For example, if there is an application, a web app, that web app could be sitting as a pod within Kubernetes cluster, or it could be sitting in OpenShift. There could be username passwords which are statically linked to an application, and then app would be using those username passwords to connect to a database. There could be, various cloud-related identities on the far right. So the applications might be hosted in the cloud, and they might be utilizing AWS IAM, for example, for their cloud identity. And then when you go to the middle section, again, your network components have their own different identities. So for example, you would recognize or use IP address as an identity of a host. Again, there are TLS certificates which can be used to identify only trusted servers. And then when you move towards human users, right? So human users' identity is also complex simply because there are so many tools out there and so many integrations in your environment that again, human identity becomes complex. How many tools would you want to integrate with and centralize that entire identity and access portfolio, so to speak? So identity is a key element definitely to zero trust. And when we talk about the zero trust security framework at HashiCorp, we have a couple of tools which help you build this ZTS framework. But ultimately at the heart of it is, all the tools that HashiCorp builds is designed to simplify the workflow. So today, when we talk about Boundary, let's try to understand where it fits in to the Zero Trust security framework. So I think if you attended the past sessions, one of the component was HashiCorp Vault. Of course, it helps you authenticate and authorize machine workloads. The last session in the series was Consul, which was connecting different applications, so machine-to-machine access using MTLS, so mutual TLS certificates, using service discovery, service mesh, and how did we then achieve that in elastic, EKS or ECS services within AWS. And so today, we are talking about the other half of the puzzle, which is human-to-machine access. And again, it's the critical component of your ZTS framework. And that is where Boundary helps us to automate and secure remote access. As a human user, when I want to SSH to a server or RDP or connect to a database, how can we automate and simplify that based on identity? And the last component of ZTS framework is, of course, authentication and authorization using single sign-on mechanisms. So obviously, HashiCorp does not provide a single sign-on tool, meaning we do not provide identity providers such as Okta, AD, SailPoint, Ping Identity, but all our tools integrate with the SSO providers. So with those 4 components, your ZTS framework is complete, and it helps you build identity-driven controls around your entire application environment. So when we talk about human-to-machine access, what does that mean? So in simple words, it means it's remote access, right? Whenever you want to connect to a server to deploy something, to troubleshoot something, you would typically either SSH or, if it's a Windows server, you would RDP. And then you would need username, password, or SSH keys to connect to that server. Or you would first connect to a Bastion host, and that Bastion host is living or it's hosted in your private network, and only that Bastion host has access to your target servers. So in either ways, you are connecting using some sort of credentials and some sort of either Bastion host or VPN, or directly connecting to the target server. And that is the typical approach. But what are the issues with that sort of approach? The first thing is you need to have a VPN set up. You need to connect to the VPN, which actually already gives you access to the network. You need to have a Bastion host typically. And again, if that Bastion host is not managed properly, that might have build and deploy access to rest of the environment. So a lot of people do git pull or git clone on the Bastion servers, and then sort of forget that there is a git clone, a whole heap of source code sitting on that Bastion host. And so if that Bastion host gets compromised or hacked, it sort of gives away a lot of information which you never intended. So that's the first problem, right? The user already has access once they are logged into Bastion host. They already have credential access to your network. The other issue with a typical remote access control or remote access workflow is, there are firewalls which are IP based. And again, in a dynamic world where there are, Kubernetes pods, Docker containers, or even EC2 instances that are dynamically created and destroyed, IP addresses are no longer static. So you cannot rely on IPs and, IP based firewalls. The next issue is, of course, how do you distribute the credentials, right? So if you are baking in SSH keys or username passwords into your target server or Bastion server, then first of all, you need to do that image management and key updates, continuously rotate the credentials yourself and update on the target servers. And then second thing is, how do you distribute these credentials to rest of the team? And how do you make sure that if you are distributing the credentials to me, I am storing them in a safe place? Maybe I'm not using one password or password manager or AWS, a secrets manager, and maybe I'm storing the credentials in clear text in CSV. So again, this is all distribution issue around credentials. And then the next issue with a typical approach is once you distribute the credentials, you have already exposed the credentials. You have given away the SSH key, you have given away the username, the password. So it's already exposed to the end user. So how do we mitigate these issues in a modern world where everyone is preparing or maybe already on a multi-cloud journey or a hybrid cloud journey? And also they are using dynamic provisioning or ephemeral environments where you have a fleet of servers already provisioned, and probably the testing is over or the release cycle is over. You don't need this environment and you are going to now destroy that fleet of servers. How does a modern workflow look like? And what are the key elements that we are looking for in a solution? So the first thing is we are looking for a human-to-machine remote access solution that is developer friendly, that does not add any additional overload on developers, that, hey, I have to learn another tool if I want to access my remote server. And then we want that solution to be cloud agnostic, so we are prepared for the future. We also want passwordless capability, because the best way to not expose a password is to not have it in the first place. So we are not saying that Boundary will not generate a password, or it will make you go passwordless, but at least it will not expose it to the end user. So it will give you a near passwordless experience. And again, what we want is it needs to be just in time. So we don't want the passwords to be long-lived, and we want just-in-time access, which can have a time to live. And then again, we want to have visibility across what is an end user doing after connecting to a server. Are they trying to destroy certain files? Are they trying to access passwords? Are they trying to change, sudo and change some configurations? What are the different things that they're trying to do after getting access? Because that will actually give you insights into malicious behavior, and a lot of security teams use that for predicting malicious behavior and mitigating any attack or any risk that they pose. So with that basic minimum criteria, if we are able to fulfill these points, that will give us a modern access workflow. And that will solve all the problems that we discussed, like, IPs are brittle, and so we may not want to rely upon IPs. We may not want to give them the network access. We may not want to expose the credentials. So all those issues get solved with such a solution in a modern world. So what does that solution look like? So if I were to introduce Boundary, pretty much, Boundary has basically the identity-driven approach, and Boundary can integrate with all different identity providers. That includes any traditional OIDC, Azure AD, Okta, Ping, Auth0. And with that, it gives you the role-based access control, the membership, the role and group mapping, and you can control which user has access to which servers, VMs, Kubernetes cluster, databases, or APIs. And so once you have defined that, role-based access, then what Boundary can do is it can go and connect you through a single portal, a single dashboard to all the VMs. So for example, EC2 instances in AWS. It can help you connect to databases, to Kubernetes clusters, to even APIs. So softwares or tools that expose APIs. And then what it is capable of doing is, injecting credentials which are just in time with the help of Vault integration. So what it does is, it has the capability to provide you credentials, and you can then, yourself key in the credentials to connect to a server, or you can configure Boundary to basically inject the credentials for you. And so the credentials are never exposed to the end user. Again, all these credentials can be statically stored, or they can be dynamically generated with the integrations that Boundary has. And it also allows you to have the session recording and visibility. And you can record those sessions in an S3 bucket. Those recordings will be encrypted. So again, if anyone gets hold of the recording, there's not much they can do with it. It's an encrypted blob or an object that is stored in S3 bucket. So that's kind of an overview how Boundary solves the remote access problem. And if we were to summarize, very simply stating, what does Boundary give you? So Boundary has 3 key capabilities. First one is passwordless authentication. As I said, it's identity based, and again, it has capability to inject your credentials into the server. So when you are SSHing or connecting to a server, you don't need to key in the password. That is automatically injected. The second one is automated host discovery. What that means is, Boundary has capability to look at the tags within AWS, and it can search all the hosts, all the EC2 instances which have that particular tag. So it will automatically generate a catalog of hosts, or a target catalog. So you don't need to manually enter every single server that comes online, that, hey, this is a new server and can Boundary control access to this server, because Boundary can automatically detect and using the tagging, and it will generate that host catalog automatically for you. And then the last, obviously, is session recording and session visibility. So as I said, you can create an S3 bucket in AWS, and then Boundary can push all the recordings in an encrypted format as an encrypted object within that S3 bucket. And so that gives you the playback capability. So let's dig into those 3 topics in more detail, like how does Boundary do all these 3 things? How does a remote access workflow look with Boundary? If you see at the center of this circle is Boundary, and what it is doing is it is interacting with different softwares or different tools in order to give you the identity-based access or the role-based access control. So whenever a user tries to log into Boundary, first of all, Boundary will go and authenticate the user against the configured identity provider. So on the right-hand side, you can see that there are various identity providers that are supported, and Boundary can integrate with GitHub, AWS, cloud-based IAM, Okta, Ping, LDAP, Azure AD, so on and so forth. So all the major identity providers. And that's how it does your role-based access control, your mapping, permission mapping. And then it authorizes based on the organization and projects that you configure within Boundary, whether this user has access to this project and whether this user has access to certain servers or services. So then it can, once it has authorized, it can then generate and inject, dynamic credentials into a target server. So how does it do that? It does that because it can integrate with HashiCorp Vault. So if you want to do dynamic credential generation, you will need to integrate Boundary with Vault. If you want to store static credentials, maybe username, passwords, or SSH keys or private keys into Boundary, it can do that on its own. And in either way, you can define time to live. So whenever you request for a credential, Vault will generate the credential just in time with the time to live, and it will expire when the TTL is finished. And so that way, Boundary can fetch the JIT credential, and then it can inject it into, variety of workloads like databases like RDS instance in AWS or EC2 in AWS. And then the third thing is, how does it identify, the workloads or the targets that you want to connect to? So it can connect to AWS account. When you configure Boundary, you can configure which, AWS account you want to connect to, and you can provide the access key to Boundary, and Boundary can then go and look for, it will scan for the tags that you have configured, and it will generate a dynamic catalog. So this is sort of the workflow that I was trying to explain. If you look at the diagram from left to right, as a remote end user, I would first log into Boundary. Either I log into Boundary using username, password within Boundary, or if Boundary is integrated with Azure AD, or in this example, it is showing Azure AD account, or if it is integrated with Okta, then the first screen the user would see is typical Okta or Azure AD or Ping, login screen. Once you have logged in via SSO, then in Boundary, you would see a list of targets that you can connect to. So on the right-hand side, I've listed a couple of targets that are supported. So, Linux servers, Windows servers, Kubernetes clusters, databases. So it can show all the targets that you have access to, and then you can click on a target and simply connect to that target. So how does it connect to that target? First of all, either if the target has public access, Boundary can connect to that target through, Boundary managed workers, so HashiCorp managed workers. But if the target lives in a private network or a private VPC, a private subnet within a VPC, then you will need to install a self-managed Boundary worker, and that worker should have access to this, target server sitting in your private subnet. And then Boundary can use that self-managed Boundary worker in order to connect to your target server. Now, to connect to that target server, Boundary will need credentials. So it can then integrate with Vault, and Vault can generate dynamic credentials. If you don't want dynamic credentials, you can still use Boundary itself without Vault, and Boundary can store your static credentials, and Boundary can inject those credentials into the target server. The way Boundary works is there are obviously three components here on the screen. The first one is Boundary Controller, which is nothing but part of the Boundary server running in the server mode. There is a Boundary Worker. The Boundary Worker can be HashiCorp managed if you are using, HCP Boundary, which is the cloud or the SaaS offering. If you are using community offering or self-hosted enterprise Boundary, you will need to install, a node. Simply, it's an EC2 instance that has a Boundary binary installed on it, and a Boundary, client or a worker running on it. This worker can then go and register itself with the server, and that's how, it then communicates with the server. The third component is Boundary Client. So as an end user, right, how do I connect to Boundary? So I will have to download a Boundary client. I'm using a Mac, so I have downloaded using Homebrew. So you can do a brew tab and you can install a Boundary client and then simply log into it, and it will connect to the Boundary server. So for those who joined a little bit late, just to mention that if you have questions, please pop your questions in the webinar chat, and Melanie or myself will keep an eye on the chat. And if you want to wait for another 15-20 minutes, then I'll open the floor for questions anyways. So feel free to unmute yourself and ask questions. So with that understanding, like how Boundary works, there is a Boundary controller, there is a Boundary worker that can live in the private subnet, and that will have access to connect to your target servers. And then there is a Boundary client, which is on the remote user side. So for example, when I demo, I will have Boundary client installed on my Mac. And so similarly, you can install it on your Windows laptop or your Linux machines as well. So if we go back a slide or two, just want to recap. These are the three things that we want to discuss today. So the key capabilities of Boundaries: how does it provide passwordless experience when you are connecting to a target server? How does it do dynamic discovery of hosts? And then session visibility. So let's discuss one by one these topics. So the first one is passwordless authentication. I think the best way to protect a password or a credential is to not have it at all. But we are not in a position in most of the organizations where we are passwordless. But at least what we can do is not expose that password. If we have a password, if we have an SSH key, if we have a credential, the least what we can do is not expose it. So what Boundary helps you do is it's called credential injection. Either you can store static credentials within Boundary, and it will still inject it into the target server. So when you try to connect to a server and you want to SSH, either you use a username password or you use an SSH key. Boundary can inject that into the server using the worker. So in the previous slide, we discussed there is a Boundary worker here, and that Boundary worker has access to your target server. So this worker can actually go and inject the key and the passwords, basically the credentials, into the target server for you. So that way, the remote user actually never has to key in the password or the SSH key. And that gives you the credential injection or passwordless experience. If you want dynamic credentials, as I mentioned a couple of times, you can integrate with HashiCorp Vault. And Vault has that dynamic password or dynamic credential generation capability. So it will generate an SSH key, it will generate a password, it will generate, any sort of database credentials dynamically. It can generate TLS dynamically if you need, and then all of that can be fetched by Boundary, and it can inject them into your target server. The other thing, as I said, it does is credential brokering. So when you are not injecting credential, you are actually sharing the credential or exposing the credential to the end user. And obviously, Boundary can do that. It will give you like an SSH string, like, okay, copy and paste the string and go and connect to the server. So it can obviously fetch credentials from Vault, which is why we call it brokering, because it's not typically storing it within itself. It's brokering it from Vault and then sharing it with the end user. And then the end user keys in the password, and that's how they then connect to the target server. So what are the different types it can fetch from Vault? It can fetch things like username passwords. It can fetch things like public keys, API tokens, SSH certificates. All those kind of types of credentials can be fetched from Vault and can be then exposed to the user, so then the user can enter and connect to the target server. So then, it's good if there is one server, but how do you manage the situation when there are hundreds of servers, thousands, if not? And also when the servers are ephemeral, meaning that, your target fleet of servers is never going to be constant or static. In today's world, there are going to be a lot of situations where you've provisioned maybe 10 or 20 servers in a fleet. You are going through a release cycle, and then you probably need 10 to 20 servers as part of that release. Once you have gone through integration testing, system testing, and once you have released a particular version, you now no longer need that fleet of servers. And so you might actually destroy that entire fleet. And how do you then manage that dynamic infrastructure where the servers are ephemeral or short-lived, and they are appearing and disappearing automatically or dynamically? So if you look at the tool, right, if you look at any privileged access management tool, in this case, Boundary, you would have to go back to Boundary and then reconfigure all your hosts, or maybe write some automation. But that would be cumbersome. And in order to solve that problem, what Boundary does is it goes and scans all the tags in AWS. So for example, you have one account that is dev account in AWS, and that manages your dev environment. Again, you have a test environment, you have a pre-prod or a prod environment. In all different environments, you can have different tags, and you can give tags like environment equals dev, environment equals prod. And again, you can add more tags specific to applications. So for example, application name equals payment, application name equals shopping cart. And then based on those tags, Boundary can go and scan your AWS account. And it will scan all the hosts based on those tags and generate a dynamic catalog. So it actually reduces a lot of operational toil. And you don't have to construct your host catalog and then grant access to every single host in that catalog, because Boundary does that automatically for you. How does it do that? As I said, it uses the AWS tagging capability. And then the last topic that I want to discuss is one of the key capabilities of Boundary is, it does session recording. So what that means is, as an admin user, you can enable session recording for the target workloads. And then you can configure an S3 bucket, and you can store that session recording into that S3 bucket. Now, a lot of security teams do play back these recordings to do, understand whether there is any malicious pattern after people access certain servers. And if you actually notice anything that is malicious, you can go and terminate that session immediately. So as an admin of Boundary, you have that ability to terminate a session which you think is malicious. And so in today's demo, I don't have a session recording, but what I did was I captured a recorded session here, where you can see that, it's available under the session recordings menu, and you can see what a user is trying to do after connecting. So in the recorded session, it will actually show you things like the user is typing a command to check the passwords. It's trying to copy all the passwords from etc password into a text file, and then they're trying to copy that text file over to probably another server. And so they are trying to steal all the passwords that are stored on this server. And so you can see that sort of playback and recording with Boundary. And before I move on to how Boundary looks like, one note on what are the different identity providers that Boundary connects with. So Boundary connects with anything that supports OIDC or JOT token-based authentication. It supports traditional LDAP servers. It supports Active Directory, Azure AD, GitHub, Ping Identity, Okta, Auth0. So all the major identity providers out there today, they are supported by Boundary, and Boundary can integrate with that to give you the single sign-on capability and role-based access and access management capability with that integration. So one thing to note is, because Boundary falls into sort of a critical access management category, the security teams generally have a mandate to provide audits, audit reports. And so Boundary supports that by publishing its audit logs and providing that capability to ship the logs and metrics to any sort of SIEM tool. So you can ship these metrics to a variety of SIEM tools, including Datadog, Elk Stack, Elasticsearch, Logstash, Kibana, Prometheus, Grafana, that sort of logging and monitoring tool stack, or Splunk. So it goes and allows you to ship all your logs and metrics to their choice of your choice of tool, and then you can sort of generate lots of audits, audit reports, and also you can monitor user activity. You can monitor any sort of events that you're interested in. So that's one thing to remember as well, that it supports Elk Stack, Datadog, Prometheus, and any other typical SIEM tool such as Splunk. So if you have any questions, please post them in the chat or in the Q&A tab, wherever basically wherever you feel comfortable. I'll take a minute's pause just to check if there are any questions. So there is a question from someone. I'm sorry, Maljavan. Maybe I'll just ask you to unmute yourself, and you can ask your question around the machine-to-machine access.
Yeah, I think, sorry, thanks for that. In one of your slides, you mentioned that Boundary can actually support host to machine-to-machine authentication as well, right?
No.
No?
I think I mentioned that in the Zero Trust security framework. So HashiCorp considers, a couple of aspects which are important for Zero Trust security. In order to achieve Zero Trust security framework, you need to do a couple of things, right? So if I go back to the slide where I presented that. I think the first couple of slides, this one, right?
Yep.
Yeah. So in order to achieve Zero Trust security, what do you need, right? So you need the 4 elements that are listed here. So the first element, if I start from the far right, the first element is single sign-on, right? You need some sort of identity provider like Active Directory, Okta, to actually provide you that identity, which stores the human identities or the service accounts or and any sort of identity. So that is the first element. The second element is once you have got an identity provider like Active Directory or Okta, now you need the remote access capability. So how do you provide that human to machine remote access? So typically what people do is you connect to a Bastion server or Bastion host, and then from there you are connecting to your target server so that you don't have to grant access to your target server to hundreds of developers. Instead of that, you're just granting access to one Bastion host. So what Boundary goes ahead, one step ahead, and it does is that you don't even need that Bastion host. You can connect directly to the target server without exposing IP address, without exposing SSH key or username password. And Boundary will authenticate you based on your single sign-on or based on your Okta LDAP integration. Then once you have sorted the human access, there are other elements in order to achieve zero trust. So the third element is machine-to-machine access, meaning there is application A and it needs to connect to database A, but you don't need necessarily application B to connect to your application A database, right? So how do you even control that sort of machine-to-machine authentication? And how do you put application firewall rules in place that this app is able to talk to app A is able to talk to app B, but app A is not able to send any sort of API calls, or it's not able to make any calls to app C. So how do you define that application firewall in a more easier way to explain? So that is what we mean by machine-to-machine access. And usually it is done through service mesh and Consul, which is the other tool. What that does is it gives you a dictionary of all the applications, and it helps you define the intention and application level firewall rules using the service mesh and service discovery capability. So that is machine-to-machine access is covered by Consul. And then once you have done that, then you want to move to sort of secret management, data encryption, dynamic passwords, dynamic credentials. So that sort of authentication is provided by Vault. So Vault is pretty much helping your machine or an application to connect to a database using a dynamic credential. It can help your two machines to authenticate with each other using MTLS by generating TLS certificates. So that TLS certificate generation on demand, that is done through Vault. So if you combine all these four elements, then you are able to achieve zero trust security. And that's where I suppose I discussed about machine-to-machine access. But Boundary doesn't do that. Boundary is simply, privilege access management or remote access from a human to a target server.
Yep. Okay. All good. Thank you.
No worries.
Hey, hi, Nalini. This is Zen. I would like to understand that how the network will work. Let's say from my laptop, I'm trying to connect an EC2 machine, which is into the private subnet.
Mm.
So can you just explain me the network workflow?
Yeah, I think I had a slide here, but let me go back to that. So basically, you need to have a Boundary client, which I have here. Are you able to see my screen still?
Yes.
Yeah. So basically, I have a Mac and I installed this Boundary client. So what I do is I log into that Boundary client. So for example, I log into client. This client goes and connects to the Boundary server, right? It goes to the Boundary server and it fetches that, hey, Nalini is logging as an admin. What sort of targets or what sort of servers is she allowed to connect to or SSH to? So I can see, 2 servers that I'm able to connect to. And then I can go and, connect to one of those servers. So for example, I connect to this application server 02. It will basically simply, enter the username and SSH key on my behalf. So, I have not entered any credential, it's just connected me. And if I click on the shell, it will show me the shell of this target server. So I don't have not necessarily, the network permissions, but the boundary worker has that permission. And boundary worker is present in the same subnet as the target server. So this target server is, again, I'm not exposing the actual IP address. So what I see as an end, yeah, so as an end user, I see 127.0.0.1 and this port number. But actually, that's not the server. The server is probably this one. So I'm connected to this, target server, and then, I can do all sorts of, activities or, yeah, I can actually, check yum update, something like that. So I'm actually connected to that system. How it is doing that is, so if I go to the sessions, right? So at this point, I can see that I'm connected to app server 2. This is same like PuTTY, right? If you use PuTTY, in PuTTY, you would see a list of sessions that are open, PuTTY sessions, and which servers are you connected to. So you can take a look at all the sessions that are open currently, and you can go and go back to that particular session and work in that shell. How that does that, right? So if I go to now the server, right? So this is my Mac, and on my Mac, I've got this Boundary client. It actually goes and connects to a Boundary server that is running on HCP platform. So this is a SaaS offering. So if I go to, my SaaS offering here, so HashiCorp has something called HashiCorp Cloud Platform. And you can sign into that cloud platform for free. You can create a free account and you can try these tools. But if I sign into my cloud platform, you would see that there is a Boundary cluster. So this is my Boundary cluster, and this is the server which is running in again AWS. It is 100% managed by HashiCorp. And on this cluster, basically, if I go to the admin UI, right? So because I'm acting as an admin user, so I can go to the, admin UI and I can actually see what is inside my Boundary cluster. So inside my Boundary cluster, there is an organization. I've called it my dev org. I've got a project that's called AWS, dev account project, because it's connecting to my, AWS, dev account. So in my AWS dev account, I have, a boundary worker again that is sitting in the same subnet as my target server. And then I've got 2 instances running here, basically, just to show that, I have tags on these instances. And I pass these tags to Boundary. So if I go into my Boundary project, and if I go to the host catalog, you can see that there is a host set defined. And in this, I mention like how to find my target host. So I give the tags, right? So I've given the tags. If the tag is environment equals dev and it belongs to application 1, then go and scan for all these type of EC2 instances. So all instances with this tag will get scanned. And it goes and it checks every 20 seconds because that's what I configured. And then it'll go and scan here, basically, and show you the list of servers. So I think in this one, it's probably just scanning one because it doesn't have, the other one doesn't have the tag. If I go to the other one and look at the tag, it belongs to another application, so app2, so hence it's not being scanned right now. But that's pretty much how it controls the scanning. So once you've got the catalog here, then you can define, sort of the targets. How do I, connect to those targets? So if I show you the target config, what I'm mentioning here is, basically go and select whatever boundary worker that is available, and use that boundary worker to connect to my target server. But you can actually apply filters here, and you can select which worker you need to use, and you can do that again based on tags. So if there is a particular tag you want to allocate to your worker EC2 instance, then you can add a tag here, and that tag will then become your filter. And based on that filter, Boundary will select a worker node, and that worker node basically should have access to your private network, or should have access to your subnet where your target server is hosted. And if there are security group rules in place that are blocking that access, then you'll need to sort of open that security group rule so that there is ingress allowed from this worker node. And then if you look at the credentials, right? So I'm not using any brokered credentials, meaning I'm not integrating Vault at this moment. But what I'm doing is I'm injecting the credentials. So I'm injecting the SSH key pair into the target server. So which is why when I connect from here, I don't have to enter any SSH key pair because it's automatically injected into my shell by Boundary. So I configured that here in the injected application credentials. And then as an admin, if I go and look at the sessions, I can actually see that this session is currently active. And if I want to terminate this session, if I think that, someone is a malicious user and they are, not safe, I can actually go and disconnect this session. So if I do a cancel, it will actually go and cancel the session, or terminate that session for me. So if I go back to my Mac client, I see that the session has been closed, and I did not close that session. It was closed by the admin here. So as an admin, you can go and terminate the session as well. So I couldn't record the session for this demo, but definitely I'll send all the links, and I'll share the slides as well. If you have any questions up until now, I'll take a pause and let me just actually check.
Yeah, Got it. Thank you. So, so there are two type of access which we can control: SSH and RDP. You said, I mean, we can also control the database access as well.
Yes, so if you provision an RDS, AWS RDS instance, then again you will have to connect to AWS RDS instance using some credentials, right? So again, you can inject those credentials or you can manage that using Boundary. So what that will mean is, you will need a typical PostgreSQL client or, an Oracle client, like a client to connect to your database, or MySQL client, for example. And in that client, you will have to enter some username password. So again, Boundary can provide you that. So it would become like a seamless integration.
But those tools like I'm connecting to the MySQL, I need to install the MySQL Workbench in my laptop.
Yes.
Correct? Uh-huh.
Yeah.
Then let's say those RDS running into the private subnet, then how the network connection will build?
So again, it happens through the worker node, right? So if I go back to, the workers, so you can actually create a worker node, and that worker node can have access to your,
RDS.
RDS.
So,
So your RDS will be in your VPC. In your VPC,
mhm,
there will be a private,
mhm,
private subnet, and probably there you can
mhm.
host this. You can host this Boundary worker probably there.
So when I'm
Uh,
making a connection from the MySQL Workbench, I'll give the IP address of worker.
you don't give any IP address. Basically, Boundary connects to the worker itself.
Okay, so when I'm using the Boundary client, it will make the tunnel uh, from
Yes,
my system to the Boundary worker.
correct.
Okay. And then I can just directly use the host name of my RDS and the traffic will be routed. Is it
That's
correct
correct.
understanding? Okay.
Yeah, that's correct. It actually creates a tunnel in the background under the hood for
Mhm.
you.
And the traffic which is going from my laptop to AWS environment, is it, I mean, what is the security in network level?
Yes, it is encrypted. It's fully encrypted. Um, yeah.
Okay. So for example, if I'm using SSH connection, so SSH itself is encrypted. So the Boundary will do another encryption on top of that?
So any traffic or any sort of, any traffic that goes through Boundary that is encrypted
Okay.
via that, it is encrypted. And then even the data that it is storing, any sort of, session related metadata or data, that is also stored in an encrypted manner.
Mhm. Okay. And the network connection from my laptop, it will be terminated at the Boundary worker level. So let's say if somebody is inspecting my IP packets, so will they be able to get the my target IP addresses?
The target IP address is not exposed because they won't be able to get the target IP address. Because if you see, if I show you what I get, I get the 127.0.0 sort of IP. So that's pretty
Okay.
much what I get.
Okay. And one more question. So let's say generally in a big organization like enterprise customer, they will be having a multi account approach. one master account, and there are many other child accounts where they will be having their workload running. So in that case, how the deployment of boundary will work?
Sorry, you're asking about multiple AWS accounts?
Correct. Yes.
Yeah, so I think there is a question from Leo as well. I think Leo asked about the same thing, that in case of multiple AWS accounts, each account has a private RDS. So do I have to deploy workers in each account, or can I use VPC peering to deploy in just one? So, when we talk about the typical or the best practices from AWS, so AWS publishes the well-architected framework guidelines. And that well-architected framework guidelines is one of these concepts where you can have a shared network account or a shared tooling account. So if you have a shared network account where you want to host all these boundary workers, then you can deploy the boundary workers in that, in that VPC or in that shared account. And then you can do the VPC peering with all the target VPCs or application VPCs that you want access to. So that way you don't have to deploy boundary workers everywhere, in every single AWS account.
Okay. And what is the architecture of boundary? So you said that you will be having one boundary controller, and there can be a multiple worker node.
Yeah.
Uh,
So in my case, in my case, there is one sort of boundary server, right? Because it's all it's a SaaS offering. It's managed by HashiCorp.
Okay.
So for me, it's one controller, but in the background, in order to achieve the high availability and disaster recovery, if you are installing it yourself, you would then have multi-AZ setup. So maybe you would have the boundary server running in a cluster, like, and have all the DR capabilities or backups in place in order to have that high availability. But for the purpose of this demo, I was using the SaaS service, so I don't have to manage it myself. It's, the high availability, the multi-AZ setup, that's all managed by the HashiCorp cloud platform itself.
So if I'm using the cloud services of HashiCorp, then what is the connectivity you need to the customer AWS account? I mean, what level of, let's say, you need some permissions, or you also need some network connectivity?
So right now I'm using the SaaS offering, and I haven't made any specific, network related configs. All I need is the access key and secret key to connect to the AWS account. So basically what you would do then is you would, create a specific AWS IAM user, and that IAM would have certain permissions within your AWS account. Like scanning, because all it does is it actually goes and scans the tags. It scans, whether there are EC2 instances to build the catalog, to build the dynamic inventory. So, you would have to then give appropriate permissions to that IAM user. I think that's all you need, yeah.
But boundary worker will be deployed at customer AWS account.
Yeah, so boundary worker is deployed inside my, VPC. I showed you the worker there.
Okay. All right.
So let me actually
Let's
jump
say,
to a couple of other questions.
okay.
Sorry about that. Let me
No
jump to.
problem. No problem. Yeah.
So there was a
Sure.
question around licensing from Ahmed as well. So how does the pricing works for this service? I think pricing works based on the number of sessions. So based on the number of sessions that you are expecting, that's HCP. I think enterprise pricing is a little bit different. Maybe Ahmed, if you can drop your email, I can actually share the pricing info with you. But it's basically based on number of sessions that you are looking to have. I think I did have a pricing sheet as well, but I did not present because of lack of time. So this is, for example, the pricing sheet. If you are still able to see my screen, typically there is a standard cluster, there is a plus cluster or plus offering, and then there is a custom, enterprise self-hosted offering. For the standard and the plus, it's something like, starting at 50 cents or 90 cents in that order per session. But when you go with enterprise offering, we also offer, multi-year entitlement, meaning you can then choose what is your average number of sessions. So how many sessions would you expect on an average monthly to connect? So for example, in my case, I am connecting to like this server. And then there could be, 10 other servers that I might connect. But am I connecting to them every single day? Maybe yes. So then, I would then calculate like there would be 30 sessions for 30 days. Every single day I connect to my app server 02. So if I'm connecting for 30 days, then that means you can count it as, like 30 sessions. So I think it's per session in simple terms. That's how the licensing works. And then you can get it more cheaper if you go for a multi-year entitlement. There was another question from Ludwig. I think he asked, how can you use this in a PAM scenario? I think so Boundary is a privilege access management solution. I think there was a slide where I was trying to explain the PAM scenario. Maybe let me go back to the workflow for you, Ludwig. So does this slide sort of answer your question? Or maybe you can unmute yourself and please elaborate on the question.
Yeah, I think I just missed it. That's all. Yeah. Thank you.
No worries. Cool. So does anyone have any other questions? Sorry, I interrupted someone while they were asking.
Hey, Nalini. So how, Boundary protects me with DDoS? So because why I'm asking this, let's say Boundary controller and Boundary worker, these two instances will be having the public connectivity. They will be exposed in a public network, and they may become the target of DDoS attack. And now because I'm using the Boundary for all my connectivity, then my all connectivity will hamper.
I think if you are using something like Akamai, you can configure on Akamai. So Akamai is most often used to prevent DDoS attacks. And you can configure Akamai to prevent the DDoS attacks on certain services. You can prevent it for Boundary service itself. I think that's one way to do. If you are hosting Boundary yourself, so meaning you are downloading the binary, a license binary or the community binary, and you are installing it on an EC2 instance, then that EC2 instance can be configured under a load balancer. So basically load balancer, multi-AZ setup, and then that load balancer can be connected to your, DNS and let's say CloudFront. So AWS offers, AWS CloudFront, and again, AWS CloudFront can be then connected to, then you can configure the DDoS attack.
So
or
boundary, boundary
web application
controller.
firewall.
Boundary controller is receiving all my HTTPS traffic.
Yes, that's correct.
So it can work behind the application load balancer. Okay.
Yeah, that's where you can attach it to a WAF, that is web application firewall. And so in AWS, you can then configure all sorts of rules, and then you can link it to the DDoS prevention rules.
And
So
boundary controllers support multi-AZ?
Yeah, so it's actually a service, right, that you are installing. Consider it as your application that, a web application that you are installing on your EC2 instance. So you can have that auto scaling group, and you can have that sort of multi-AZ setup behind a load balancer, right?
So
it's similar to
I can have two EC2 machines behind the application load balancer for boundary controller. Is this something correct?
I can post the link. Let me find the architecture diagram and design. Let me post that here as well. And so I think that will give you a better idea. So there is a reference architecture online, and that you can go and refer if you want to install it yourself. And that actually shows a multi-AZ setup. Let me know if you can see this one in the webinar chat. And I'm also yeah, let me also bring that up here. But that link talks about the best practice or the reference architecture that you can use to install Boundary yourself.
Okay.
So this one, are you able to see the screen that has, I've opened the link for you? Yeah, so it's actually showing you can install the controller across 3 availability zones. And so the load balancer will then pretty much route the traffic and, across the 3 availability zones.
Okay.
Yeah, so this document goes into detail, like, what is the hardware sizing, and what is the network consideration, what are the network connectivity aspects that you need to be mindful of, what are different port numbers that you need to open up, etc. So definitely go through this guide. It's useful, actually.
Okay.
Cool. So let me actually stop sharing the screen, and if anyone has any questions, please post in the chat. And thank you for your time today, and thanks for hanging out with me even after the hour is up. this session will be recorded, and as Mel said, we will share the recording. It will be available to you later to watch. If you want to discuss anything, you can definitely find me. Send any questions on LinkedIn or send me an email, and I'll be happy to assist.
Thank you, Nalini.
Thank you.
No worries. Thanks for your time. I hope the session was useful.
Definitely. Thank you.
Okay, thank you. Bye-bye.
Bye.
Bye.